Hello students, welcome to Diksha Karnataka YouTube channel. In this video, I'm going to discuss COMEDK 2023 previous year paper. Okay, physics part 2, question number 31 to 60. Okay, so if you want to see the detailed solution, okay, or if you want to check the detailed solution, please join the WhatsApp channel, which is given in the description box. Okay, yeah, let's start. Question number 31. Question number 31. In the figure below, the capacitance of each capacitor is 3 microfarad. Okay, so here 3 microfarad. Okay, 3 microfarad, 3 microfarad, 3 microfarad, and 3 microfarad. The effective capacitance between A and B. Okay, we need to find effective capacitance between A and B, right? So if you look closely here, this 3 microfarad. Okay, let's name each capacitor here: C1, C2, okay, C3 and C4. C3 and C4 both are in parallel, right? So these two are in parallel, right? Isn't it? So here C dash will be equal to C3 plus C4, right? So now these two are in parallel. So then C3 and C4 is in series with C1, right? C3 and C4 is in series with C1. Then all these things, that is C1, C3, C4 is in parallel with C2, right? So if I draw the equivalent circuit diagram, so this is how it looks like. C1, okay. So this will be C dash, B, and then C2. Okay. So now we need to find equivalent capacitance between A and B, right? So now C3 plus C4 is 6 microfarad, right? C4 is 3 microfarad, C3 is 6 microfarad, right? So this will be 6 microfarad. So now A, C1, okay. Now these two are in series, right? Isn't it? So now 3 microfarad and then 6 microfarad, okay, and then 3 microfarad. Okay, so now these two are in series, right? So now here the equivalent capacitance between these two will be 1 by 3 plus 1 by 6. So 1 by 3 into 1 plus 1 by 2. 1 by 3 into 1 plus 1 by 2 is 3 by 2. So 3 by 2 into 1 by 3 is 1 by 2, right? So now this will be 2 microfarad, right? C double dash, which is equal to 2 microfarad. So now this 2 microfarad is in parallel with 3 microfarad, right? So equivalent capacitance between AB is equal to 3 plus 2 microfarad. So which is equal to 5 microfarad. So the correct option is D. Okay, yeah. The first emission of hydrogen atomic spectrum, in Lyman series appears at a wavelength of. Okay, so this one is direct one, right? So in a Lyman series, the first emission spectrum, atomic spectrum, right? So when electron makes transition from n equal to 2 to n equal to 1, we will get first emission spectrum. Here NF equal to 2, okay, sorry, Ni equal to 2, right? Ni equal to 2, NF equal to 1. Electron makes transition from 2 to 1. So now we know that 1 by lambda equal to R into 1 by NF squared minus 1 divided by Ni squared. Okay, so now lambda is equal to, solve this, you will get 4 divided by 3R centimeter. So the correct option is B. Okay, so next question, question number 33. In Young's double slit experiment, the ratio of the maximum and minimum intensities in the fringe system is 9:1. That is, I max divided by I minimum is equal to 9 by 1. The ratio of the amplitudes of the coherent sources is, okay, so we know that intensity is directly proportional to square of the amplitude. So from this I can write it as A1 plus A2 squared divided by I max is A1 plus A2 squared, A2 whole squared, okay, I minimum is A1 minus A2 whole squared divided by equal to 9 divided by 1. So now I can rewrite this equation as A1 divided by A2 plus 1 divided by A1 minus A2 minus 1 is equal to 3. Take square root on both sides, right? So now A1 divided by A2, okay, into 3, right? 3 minus A1 divided by A2 is equal to here, so this will be minus 3, then take the other 3 to the other side, you will get the 4, right? Okay, 4. So now this will be 2 times A1 divided by A2 is equal to 4. So A1 divided by A2 is equal to 2 by 1, that is 2 is to 1. Okay, 2 is to 1. So the correct option is C. Next question, question number 34. In the case of an inductor, voltage lags the current by pi by 2. Wrong. Voltage leads the current by pi by 2. So the correct option is B. Okay. Yeah. Next one, 35. The height vertically above the Earth's surface at which the acceleration due to gravity becomes 1% of its value, the surface is. Okay, we need to find height vertically above the Earth's surface at which acceleration due to gravity, right? Acceleration due to gravity G dash becomes 1% of its value, right? So at height h, acceleration due to gravity is G into r square divided by r plus h whole square, right? G dash is G by 100, right? So G by 100 equal to G into r square divided by r plus h whole square, right? So now take square root on both sides. Here G will get cancelled. So 1 by 10 is equal to 1 by 10 is equal to r divided by r plus h. So now 10r is equal to r plus h. So h equal to 9 times r. So the correct option is B. Okay. Next one, question number 36. If C be the capacitance and V be the electric potential, then the dimensional formula of CV square is. Okay, we know that energy stored in the capacitor U equal to half CV square, right? So what is the dimension formula of the energy? Dimension formula of the energy is same as dimension formula of the CV square. Dimension formula of the energy is equal to ml square T to the power minus 2 A to the power 0. So the correct option is A. Okay. Next one, question number 37. Which of the logic gate represented by the following combination of the logic gates? Okay. So let us find the output. So here the output is A complementary, that is A bar, here B bar, right? So here A bar and B bar. So now what is the output, right? So this is NOR gate, right? NOR gate. So now the output will be A bar plus B bar whole bar, right? So now we know that A plus B whole bar is A bar dot B bar. Here A bar plus B bar whole bar is A bar bar plus B bar bar. So that will be A dot B. That's it. So the correct option is C because the output of NAND gate is A dot B, right? Yeah. Next one, question number 38. An LED is constructed from PN junction diode using GaAsP, okay, gallium and arsenic, okay, gallium arsenide and phosphorus. The energy gap is 1.9 electron volt. The wavelength of the light emitted will be equal to, okay, energy gap E is equal to, here electron makes transition, right, from here the conduction band to valency band, isn't it? So what happens, the here the light will emit. So energy of the incident light, sorry, energy of the radiation is equal to energy of the so this will be gap, energy gap, right? So E equal to hc by lambda. E is 1.9 electron volt, right? So 1.9 electron volt is equal to, here 1.9 electron volt is equal to hc is 1242 electron volt nanometer divided by lambda. So we need to find lambda. Electron volt will get cancelled, right? So now lambda is equal to 1242 divided by 1.9 nanometer. So now lambda is equal to 654 nanometer. Okay, so the correct option is B. Next question, question number 39. a body is projected vertically upwards. The times corresponding to height h while ascending and while descending are t1 and t2 respectively. Then the velocity of projectile will be. Okay, so here we need to find velocity of the projectile, right? So this is how the particle is projected, isn't it? The velocity is u, right? Velocity is u. So here we know that in projectile motion, the time of flight t is equal to 2u sin theta divided by g, right? So what is the time of flight? The total time taken by the projectile to complete this path, right? Isn't it? Or this motion. So now t is equal to time of ascending t1 plus time of descending t2. So which is equal to 2u sin theta divided by g, right? So here in this case, what is the value of theta? The theta is 90 degree, right? So now t1 plus t2 is equal to 2u sin theta is sin 90 degree, that is 1 divided by g. So now u equal to g into t1 plus t2 divided by 2. Okay, so this is the one way to solve this question. Option B is the correct answer. Otherwise you have to apply second equation of motion. Okay, so from there you have to find t. Okay, you will get quadratic equation, then you will get two t values, right? So t1 and t2, right? So then you have to take t1 plus t2, right? Total time. Okay, next question, question number 40. When a certain metal surface is illuminated with the light of frequency nu, okay, light of frequency nu, with stopping potential for photoelectric current is V naught. Okay, so let us write the photoelectric equation. Here maximum kinetic energy of the photoelectron, okay, that is E into V naught. So which is equal to energy of the incident light, that is h into nu minus work function. The work function is phi. Okay, work function is phi. Phi is h into nu naught. Okay, h into nu naught. Nu naught is threshold frequency. Okay, yeah. So when the same surface is illuminated by the light of frequency nu by 2, the stopping potential is V naught by 4. The threshold frequency for the photoelectric emission. Okay, we need to find threshold frequency, that is nu naught, right? Okay, so in the second case, the frequency of the incident light is nu by 2, right? And the stopping potential is V naught by 4. So E into V naught by 4 is equal to h into nu divided by 2 minus h into nu naught. Okay, threshold frequency does not change, right? So now E into V naught is equal to 2h nu, this equation, I am rewriting this equation, minus 4 times h nu naught. Okay, so now substitute EV naught to the first equation, this equation, right? So now 2h nu minus 4 h into nu naught, right, is equal to h into nu minus h into nu naught. Okay, so now here h into nu is equal to 3h nu naught. So h will get cancelled. Okay, h and h will get cancelled. So then nu naught is equal to nu divided by 3. So the correct option is B. Okay, yeah, next one, question number 41. A fish in water, refractive index n, looks at a bird vertically above in the air. Okay, let us draw the diagram. So this is the water. Okay, so fish is at the water. Okay, and this is the bird. So fish looks the bird vertically above, right, isn't it? And refractive index of the water is n, above in the air. Okay, if y is the height of the bird and x is the depth of the fish from the surface of the water, so this is x and this is y, right, from the surface of the water, right? So this is y. Then the distance of the bird as estimated by the fish is, Okay, so we need to find distance of the bird estimated by the fish, that is from the fish, right? Okay, here the observer is in the denser medium, okay, and object is in the rarer medium, right? So we know that refractive index is real depth divided by apparent depth, but observer is in the denser medium, so therefore real depth divided by apparent depth is equal to 1 divided by refractive index of the water, okay, 1 by n. Understood? Okay, so we need to find apparent depth, right? Apparent depth is equal to real depth into n. What is real depth? Y, right? So y into n. Apparent depth equal to y into n, right? Okay, so y into n is the distance between the surface of the water and the image of the bird, right? Distance between the surface of the water and image of the bird. So we need to find distance between the fish and image of the bird, right? So distance between the fish and image of the bird, so that is x dash. X dash is equal to x plus yn, right? X plus yn. So the correct option is B. Okay, x plus yn, right? Next question, question number 42. A car starts from rest and accelerates uniformly to a speed of 180 km per hour. So in meter per second, so this will be 50. Okay, in 10 seconds. The distance covered by the car in this time interval is. Okay, here first apply first equation of motion. Car starts from rest, that is initial velocity is 0, final velocity is 50 meter per second. So now acceleration of the car A equal to 50 divided by time 10, which is equal to 5 meter per second, right? Okay, we need to find distance covered by the car in this time interval. Apply second equation of motion, s equal to ut plus half at square. Initial velocity is 0, so it will be half at squared. So now s equal to half into 5 into t squared, that is 10 squared, 100. So this will be 50, s equal to 250 meter. So the correct option is B. Okay. Next question, question number 43. A plane electromagnetic wave of frequency 20 megahertz travels through a space along x direction. If the electric field vector at a certain point in this space is 6 volt per meter, then what is the magnetic field vector at that point? Okay, we know that here electric field vector divided by magnetic field vector is equal to c, right? So c is the speed of light in vacuum. E is given, right? We need to find B. So B equal to E by C. B equal to E divided by C. E by C, right? Okay, so now here B is equal to E is 6 volt per meter, right? 6 volt per meter divided by C is 3 into 10 to the power 8 meter per second. So this will be 1 by 2. So B is equal to 1 by 2 into 10 to the power minus 8 Tesla. So the correct option is B. Next question, question number 44. The sides of a parallelogram are represented by vectors. P vector is equal to 5i cap, 4j cap, 3k cap, and Q vector is equal to 3i cap plus 2j cap minus k cap. Then the area of the parallelogram is, here area of the parallelogram is magnitude of P vector cross Q vector. P vector cross Q vector. Okay. So now let us find P vector cross Q vector. P vector cross Q vector. Okay. So I cap, j cap, k cap. So now I cap is here P vector, right? So this will be 5. For Q vector this is 3, and then minus 4 plus 2, and then 3 minus 1, right? Okay. So now here I cap, here minus 4 minus 1, that is plus 4. 4 minus 6 is minus 2. So minus 2 I cap. So minus j cap, right? So here this will be 5 into minus 1 is minus 5, minus 5 minus 9, right? Minus 5 minus 9 is minus 14. So plus 14, right? Okay. So then K cap 10 plus 12, right? 10 plus 12, that is 22, 22 K cap. So we need to find magnitude of the P vector cross Q vector, magnitude of the P vector cross Q vector, so which is equal to root of 4 plus 14 squared plus 22 squared. So now solve this, you will get root of 684 units. Okay, root of 684 square units. Square units. So the correct option is A. Understood? Yeah. Question number 45. If theta 1 and theta 2, if theta 1 and theta 2 be the apparent angles of dip observed in two vertical planes at right angles to each other, then the true angle of dip is given by. So here, so this is magnetic meridian, right? So they are asking true angle of dip, right? Theta 1 and theta 2 be the apparent angles of dip, right? Observed in the two vertical planes. Okay, so here, so this is the plane 1, okay, and plane 2. These two are mutually perpendicular plane, okay, mutually perpendicular plane, and here it is making an angle theta and 90 minus theta with the magnetic meridian, okay, theta and 90 minus theta with the magnetic meridian. So now here the vertical component of the Earth's magnetic field does not change, right? So here the horizontal component B1 is equal to BH cos theta and B2 is equal to BH sin theta, BH sin theta, okay. We know that tan theta is equal to BV divided by BH. Tan theta is BV by BH. So cot theta is equal to BH divided by BV, right? So now tan theta 1, right? So here tan theta 1 will be equal to, okay, sorry, cot theta 1, okay. I can write here cot theta 1 as B1 divided by BV and cot theta 2 as B2 divided by BV. So what is B1? BH cos theta. What is B2? BH sin theta. So now this will be BH cos theta divided by BV and this is BH sin theta divided by BV, right? So now square cot theta 1 and cot theta 2, then add, right? So now cot square theta 1 plus cot square theta 2 is equal to here BH square divided by BV squared into sin square theta plus cos square theta. Sin square theta plus cos square theta is 1. BH by BV is cot theta, right? So this will be cot square theta. So finally cot square theta is equal to cot square theta 1 plus cot square theta 2. So the correct option is here A. Okay. Next question, question number 46. Let K1 and K1 be the maximum kinetic energy of photoelectron emitted by the light of wavelength lambda 1. Let us write the photoelectric equation. Okay. So K, maximum kinetic energy of the photoelectron, is equal to energy of the incident light, that is hc by lambda minus work function W. And K2 is the corresponding to the wavelength lambda 2, lambda 1 equal to 2 lambda then. Okay, so now K1 is equal to hc by lambda 1 minus W. Okay, K2 equal to hc by lambda 2 minus W. Lambda 1 equal to 2 times lambda 2, right? So K1 equal to hc divided by 2 lambda 2 minus W. Okay, so now hc by lambda 2 minus W is hc by lambda 2 minus W is K2, right? Okay, so now K1 is equal to, take 1 by 2 as common, right? So then we will get hc by lambda 2 minus 2 times W, right? Okay, so now here K1 is equal to hc by lambda 2 minus w, right? So now take, so here this will be K2, okay, K2 divided by 2, okay, K2 divided by 2 minus W divided by 2, right? K2 divided by 2 minus W divided by 2, isn't it? So now take plus W to the other side. Now hc by lambda 2, right? hc by lambda 2 is K2 plus W, right? Okay, I will solve here. Here, so 1 by 2, right? 1 by 2 into, so hc by lambda 2 is K2 plus W. K2 plus W minus W, right? So then K1 is equal to K2 by 2 minus, this will be W by 2, right? So from this I can conclude that here K2 by 2 is greater than K1, right? K2 by 2 is greater than K1. So the correct option is C, right? K2 by K1 must be greater than K2 by 2 must be greater than K1, right? From this equation. Yeah. Question number 47. A ball is projected horizontally with a velocity of 5 meter per second from the top of the building 19.6 meter high. How long will the ball take to hit the ground? Okay. So here ball is projected horizontally with the velocity of 5 meter per second, right? From the top of a building 19.6 meter. Here 19.6 meter, right? So we need to find the time taken by the ball to hit the ground, right? So now time taken by the ball to hit the ground is t equal to root of 2h by g, right? So now t equal to root of 2 into h, right? H is here 19.6 divided by 9.8. 9.8. So now g is 9.8 meter per second square. So this is 2, right? 2 into 2 is 4. So t equal to 2 seconds. So the correct option is B. Okay. Next question. Question number 48. A galvanometer having resistance of 8 ohm is shunted by a wire of resistance 2 ohm. Okay. So here this is the galvanometer G. Okay. So this is the shunt wire. The total current I. Okay. Here the current will be I minus Ig. What is Ig? Current flowing through the galvanometer. Okay. If the total current is 1 ampere, that is I equal to 1 ampere. The part of it passing through the shunt will be, that is we need to find I minus Ig, right? So here the potential difference across G is same as potential difference across shunt resistance, that is 2 ohm. Here 2 ohm and 8 ohm. So now Ig into G is equal to I minus Ig into S, right? So let us find Ig. So now Ig into G plus S is equal to I into S. I into S, right? I into S. So now here Ig is equal to I into S divided by G plus S. I is here 1 ampere, right? S is 2 ohm. G is 8 ohm. So now Ig is equal to I is 1 into 2 divided by 8 plus 2, that is 10. So now Ig is equal to 0.2 ampere, right? Ig is 0.2 ampere. Okay. So let us find I. What is the total current? 1 ampere, right? Ig is 0.2 ampere. So now I dash is equal to 1 minus 0.2, that is 0.8 ampere. So the correct option is B. Okay. Yeah. Question number 49. In the diagram, okay, so this is I. In the diagram shown below, M and M, okay, M1 and M2. So this is M1 and M2 are the masses of two particles and x1 and x2 are their respective distances from the origin O. Okay, so here we need to find the center of mass of the system. Center of mass of the system is equal to m1 x1 plus m2 x2 divided by m1 plus m2. That's it. Okay, center of mass of the system. So the correct option is A. That's it, the direct question, right? Yeah. Next one, question number 50. A block of wood floats in water with 4/5 of its volume submerged. Okay, so here 4/5 of the volume of the block of wood is submerged, right? So what is the volume of the water displaced, right? Isn't it? Okay, let's read the question, then we can see. If the same block just floats in a liquid, the density of the liquid is. Okay, so here we need to apply Archimedes principle, right? Yeah. So here block of wood floats in water, right? So apply floating condition. Here force due to gravity acting on the block must be equal to Buoyant force, right? That is the floating condition. So now here volume of the block is V, right? So force acting on the block, gravitational force acting on the block, so rho or density of the block, okay, into volume of the block into G, which is equal to density of the water into here water displaced, right? That is equal to density of the water into volume of the water displaced, that is equal to volume of the block inside the water, right? Or submerged under the water. So that will be 4/5 times V into G, right? So now V will get cancelled, G will get cancelled. Okay. So now density of the block is equal to 4/5 times density of the wood. Sorry, density of the water. Okay, density of the water. So now we have replaced the water and we put some liquid. Okay, so now the same block just floats in a liquid, right? Again, apply Archimedes principle. Here the gravitational force acting on the block, right, RB into volume of the block into G is equal to here volume of the liquid displaced, right? Isn't it? So that will be equal to here first density of the liquid, Buoyant force I am writing density of the liquid into volume of the liquid displaced, that is V only, right, into G. So now Vg will get cancelled. Rho L is equal to rho B, right? So rho L equal to rho B is 4/5 times rho W. Rho W is 1000 kg per meter cube, density of the water. So 4/5 into 1000. So this will be 200. 200 into 4 is 800. So 800 kg per meter cube. Correct option is D. Okay. Yeah. Next question, question number 51. A balloon with mass m is descending down with an acceleration a is lesser than g. How much mass should be removed from it so that it starts moving with an acceleration a? Okay, so this is the balloon, initial case, mass m. The force due to gravity acting on this mass m is mg and the Buoyant force is b. Acceleration is a, right? So now apply Newton's second law of motion. We will get mg minus b equal to ma, right? So now we have removed some mass, right? Now the new mass is m dash. Now it is moving up, right? Buoyant force is b, acceleration due to gravity is mg, m dash g, okay? And it is a. So now apply Newton's second law of motion. B minus m dash g is equal to m dash a. Okay. So now here b equal to m dash into g plus a, right? So now substitute b to first equation. So now mg minus here m dash g minus m dash a equal to ma. right? We need to find m dash, right? So now mg here, okay, here m dash into g plus a equal to m into g minus a, right? Okay, we need to find m minus m dash, not m dash. Okay, so now m dash is equal to m into g minus a divided by g plus a. Okay, so now m minus m dash, we need to find m minus m dash, right? That is the delta m equal to m minus m dash. So now delta m is equal to m minus, okay, take m as common. Okay, take m as common, take m as common. So now this will be 1 minus g minus a divided by g plus a, right? So g plus a minus of g plus a, right? So this will be 2ma, right? 2ma divided by g plus a. Delta m equal to 2ma divided by g plus a. So the correct option is A. Okay, yeah. Next one, question number 52. A straight wire of length 2 meter carries a current of 10 ampere. Okay, the length of the wire is 2 meter, okay, carries a current of 10 ampere. If this wire is placed in uniform magnetic field of 0.15 Tesla, making an angle 45 degree with the magnetic field, the applied force on this wire, right? Okay, so applied force on the wire, F equal to B into I into L sin theta. B into I into L sin theta. Theta is 45 degree. Angle between L and B, that is 45 degree, right? So F equal to here 0.15 into I is 10 ampere, right? 10 ampere, and the length is 2 into sine 45 degree, that is 1 by root 2. So 2 into 0.15 is, so this will be 15 into 10 to the power minus 2, 30. So this will be 0.3. 0.3 into 10 is 3, right? So F equal to 3 divided by root 2 Newton. That's it. So the correct option is D. Okay. Next one, question number 53. Two slabs are two slabs are of the thicknesses D1 and D2. D1 and D2, their thermal conductivities are K1 and K2 respectively. They are in series. The free ends of the combination of these two slabs are kept at the temperatures theta 1 and theta 2. Assume theta 1 is greater than theta 2. The temperature theta of their common junction is. Okay, let us draw the diagram. Here, this is the slab. Okay, thickness is D1 and D2. This is D2 and D1. Here at this end, the temperature is theta 1. Here the temperature is theta and theta 2. Okay. So we know that heat current H equal to K A delta theta divided by D, right? So here heat transfers, right, from theta 1 to theta 2. So theta is the common junction, right? We need to find the value of theta. So now H1 is equal to K1. Okay, H1 is equal to K1 into A into theta 1 minus theta divided by D1. Okay, here H2 is equal to K2 into A theta minus theta 2 whole divided by D2. Okay, so here at this point H1 is equal to H2, right? So K1 A theta 1 minus theta divided by D1 is equal to K2 A theta minus theta 2 divided by D2. Okay, so now solve this. You will get theta is equal to, here A will get cancelled, right? A will get cancelled. K1 theta 1 D2 plus K2 theta 2 D1, okay, divided by K1 D2 plus K2 D1. So the correct option is C. Okay, yeah. Next question, question number 54. A square wire of each side L, okay, carries a current I. The magnetic field at the midpoint of the square, okay, we need to find magnetic field at the midpoint of the square. So we know that the magnetic field due to the current carrying straight wire is mu naught B equal to mu naught I divided by 4 pi r into sine theta 1 plus sine theta 2. Okay, so here let us find theta 1 and theta 2. Here there are 4 wires, right? Isn't it? Magnetic field at point O due to the first wire is into the plane, second wire into the plane, third wire into the plane, fourth wire into the plane, right? Okay, so here, so what is this angle? So anyway, this angle is 45 degree. So this angle will also be 45 degree, right? And this angle will also be 45 degree, isn't it? So now magnetic field B due to the first wire, this is the first wire, second wire, third wire and fourth wire. Okay, so B1 is equal to mu naught into I divided by 4 pi. So this side is L by 2, right? The side is L. Now the half of the side, that is from this side or this wire to the center, the distance will be L by 2. Okay, L divided by 2. Sine theta 1 is 45 degree, that is pi by 4 plus sine pi by 4. Sine pi by 4 is 1 by root 2. So 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 is root 2. So B1 is equal to here 2 mu naught I divided by 4 pi L into here 1 by root 2 plus 1 by root 2 is 2 by root 2. 2 by root 2 is root 2. So into root 2. So how many sides are there? There are 4 sides, right? Isn't it? So the magnetic field at the net magnetic field at O will be equal to 4 times B1, right? So B naught or BO is equal to 4 into 2 is 8. 8 into root 2 into mu naught I divided by 4 pi L. So the correct option is B. Okay, yeah. Next one, question number 55. A cylinder of radius r and of the thermal conductivity K1 is surrounded by a cylindrical shell of inner radius r and outer radius 2r. Okay, so let us draw the diagram. So this is the outer shell, this is the inner shell, okay, r and 2r. Made of the material of thermal conductivity K2. The effective thermal conductivity of the system. Okay, we need to find effective thermal conductivity of the system, right? So this is K1. Okay, so this is K2 and this is K1. So now these two cylinders are in parallel, right? So these two cylinders are in parallel. So here for parallel, the net conductivity K net, okay, or K, okay, K equal to here K equal to K1 A1 plus K2 A2 divided by K1 plus K2, right? A1 plus A2. Okay, so this will be A1 plus A2. K1 A1 divided by K2 A2. K1 A1 plus K2 A2 divided by A1 plus A2. A1 is area of the smaller cylinder, A2 is area of the bigger cylinder, right? So now let us find the area of the bigger cylinder. Area of the bigger cylinder is equal to pi of 2r whole square, 2r whole square, here pi of 2r whole square minus pi into r square. So now A2 is equal to 3 pi r square. Okay, A2 is equal to 3 pi r square. So now K, the net conductivity or effective thermal conductivity of the system. So K1 into A1, A1 is here pi r square plus K2 into pi into 3r square whole divided by A1 plus A2, that is 3 pi r square plus pi r square. So take pi r square as common. Okay, pi r square will get cancelled. So now K is equal to 3 plus 1 is 4. So 1 divided by 4 into K1 plus 3K2. So the correct option is here D. Okay, yeah. Question number 56. The speeds of airflow on the upper and lower surfaces of a wing of an aeroplane are V1 and V2 respectively. If A is the cross-sectional area of the wing and rho is the density of the air, then upward lift. Okay, so here this is the aeroplane wing, right? On upper surface, the velocity of the air particle is V1. On lower surface, at the lower surface, velocity of the air particle is V2. Okay. Here we consider h as 0. Okay. The height difference as 0. So now, because of the okay. So here, on the upper surface of the aeroplane wing, the air particle moving on the upper surface of the aeroplane wing is faster compared to the lower surface, right? So because of that, there will be a pressure difference, right? Isn't it? At this point, the pressure is greater compared to upper surface, right? On lower surface, pressure is greater compared to the upper surface. Because of that, there will be an uplift. Okay, so now we need to find uplift, that is force, right? So we know that pressure into area, right? Pressure into area is force, right? Okay. So now apply Bernoulli's equation. P plus half rho v square pressure energy plus kinetic energy is equal to constant. Potential energy is there, but it is 0, right? Because the height difference is very small. So we consider it as 0. Okay. So now P1 plus half rho into V1 square is equal to P2 plus half rho into V2 square. Right? So now P2 minus P1 is equal to half rho into V2 square minus V1 square. Right? Okay, so now P2 minus P1 is the pressure difference, right? That is force per unit area, right? So force is upward lift is equal to half rho A into V2 squared minus V1 squared. So the correct option is here. Okay, if I take P2 minus P1, right? So this will be half rho A. Okay, so this has to be V1 square, right? Okay. So this will be V1 square minus V2 square. Sorry, here this will be V1 square minus V2 squared. Okay. So here this will be V1 squared minus V2 squared. So the correct option is C. Understood? Yeah. Next one, question number 57. Two cells with the same EMF E and different internal resistances R1 and R2 are connected in series to an external resistance R. If the potential difference across the first cell is 0, then value of. Okay, here the EMF is E and internal resistance R1. Here EMF is E, internal resistance R2. Okay. Sorry, here this will be the resistance, external resistance R. External resistance R. Okay. So here, according to the question, potential difference across one cell, right? Here the potential difference across the first cell is 0, right? Potential difference across the first cell is 0. So now here the current flowing through the circuit I into R plus R1 plus R2 is equal to 2E, right? I into R1 plus R2 equal to 2E. So now the current I equal to 2E divided by R plus R1 plus R2, right? Current I equal to 2E divided by R1 plus R2, capital R divided by R1 plus R2. So now the the potential difference across the first cell is 0, right? Potential difference across the first cell is 0. So now here the potential difference across the first cell V equal to E minus I into R1, right? V equal to E minus I into R1. V equal to 0. So E equal to I into R1, right? V equal to E equal to I into R1. I is 2E, right? Sorry, I is 2E divided by R plus R1 plus R2. So now E equal to 2E R1 divided by R plus R1 plus R2. So now E will get cancelled, right? So now R plus R1 plus R2 is equal to 2R1, right? So now R equal to R1 minus R2. So now the correct option is C. This is the external resistance, value of external resistance. Next question, a string vibrates with the frequency of 200 Hz when its length is doubled and tension is altered. It begins to vibrate with the frequency of 300 Hz. The ratio of the new tension to the original tension is. Okay, so we know that the frequency of the wave in the string nu is equal to 1 divided by 2L into root of T divided by mu. Okay, T is tension in the string, mu is mass per unit length, L is the length of the string, right? Okay, so from this I can conclude that the tension in the string is directly proportional to nu square into L square. Okay, tension in the string directly proportional to nu square into L square. So now T2 divided by T1 is equal to nu2 into L2 divided by nu1 into L1 whole squared. Okay, so what is nu2? The frequency 300 Hertz. Here nu1 is 200 Hertz. Okay, and L2 equal to 2 times L1, right? L1 is L1 only. So now T2 divided by T1 is equal to nu2, that is 300 divided by 200 into 2, right? 2 L1 divided by L1. L1 will get cancelled, square is there. Okay, so now here this will be 100 will get cancelled. So finally answer T2 is to T1 is equal to 9 is to 1. So the correct option is A. Okay, next question, question number 59. When 10 to the power 19 electrons are removed from a new material, okay, new metal plate, the electric charge on it is, we need to find electric charge on the metal, right? So we have removed 10 to the power 19 electrons, right? Isn't it? So metal, the charge on the metal will be positive, right? Because we have removed the electron. So apply quantization of charge, Q equal to N into E. How many electrons we have removed? 10 to the power 19, right? So N equal to 10 to the power 19, right? So we need to find charge on the metallic plate. So now Q equal to 10 to the power 19 into, so what is the value of charge? E, that is 1.6 into 10 to the power minus 19. So 10 to the power minus 19, 10 to the power minus 19 will get cancelled. So Q equal to 1.6 coulomb. So the correct answer is B, plus 1.6 coulomb. Okay. Next question, question number 60 and the last one. In an electric circuit, RLC and AC voltage source are all connected in series. Okay. L, R, C, all of them are connected in series. to a AC source, right? Sorry, this is L, R, C. When L is removed from the circuit, the phase difference between the voltage and the current in the circuit is pi by 3. Okay, we know that tan phi equal to XL minus XC divided by R. Okay, so here L is removed, right? L is removed, so it is purely capacitive circuit, right? So now tan phi becomes pi by 3. So pi by 3 is equal to, so tan phi by 3, right? Phi equal to pi by 3, not tan phi equal to pi by 3. Tan pi by 3 is equal to XC by R, right? So XC tan pi by 3 is root 3, right? So root 3 times R. Okay. If instead C is removed from the circuit, the phase difference is again pi by 3. Okay, we have removed the C. Again the phase difference is pi by 3. So tan pi by 3 is equal to XL by R. So XL is equal to root 3 times R, right? The power factor of the circuit, that is we need to find cos phi, right? So what is the value of cos phi, isn't it? So here the value of XL equal to XC is same, right? XL equal to XC is same. So now the power factor cos phi will be equal to 0, right? Sorry, tan phi will be equal to 0. Here the phase difference tan phi will be equal to 0, right? XL is root 3R, XC is root 3R. So this will be 0 divided by R. So tan phi equal to 0. Tan phi equal to 0 or 0 degree, right? Isn't it? So phi equal to tan inverse of 0. Tan inverse of 0. So when we will get tan inverse of 0? 0, pi, 2 pi and so on, right? So the phi value must be equal to 0 degree, right? The phi value must be equal to 0 degree. So now cos phi, we need to find power factor. Cos phi, that is cos 0 degree equal to 1. So power factor is 1. So the correct option is C. Okay. Yeah. Thank you so much for watching this video. If you love this video, please like and share. And if you want to watch more such videos, please subscribe. Thank you.